All right, here's our tank problem. We have a 90-gallon tank with it's got some 90-gallon capacity. It starts with 60 gallons of a solution in it. The solution has a concentration of 1/4 pound per gallon. And then we got some flowing in that's 4 pounds per gallon, so it's more than that, 1/4 pound. And then it's draining at a rate of 8 gallons per minute. So, it's coming into the tank at 8 gallons per minute, and then it's draining the tank at 7 gallons. So the 8 gallons is more than 7 gallons, so that tells us that the volume is increasing. They want us to find a Q of T. So we're going to go ahead and start by drawing our tank. So I like to just draw a little tank like this so I can kind of get all of the information that's going on here. All right, so what do we have? We have coming in 8 gallons per minute and 4 pounds per gallon. And then my V0, the initial volume, is 60 gallons. Vmax, so the max volume of this thing, is 90 gallons. And then Q of 0, the initial amount, Q for quantity, is equal to 15 pounds. How did we get 15 pounds? We take 1/4 pound per gallon and multiply it by 60. So 15 is 1/4 of the initial volume. Q is the pounds of the salt in the tank at any given time, so total amount. And then we're flowing out at 7 gallons per minute. So to set up this differential equation, I should say this here is what I'm going to use for my initial condition. So Q of 0 is equal to 15. So that's going to eventually help me solve for my C. All right, so what are we going to do? We're going to do Q prime, which I'll write dQ dt for now, equals, I'm going to go in minus out. In, so what I need to do is look at units. What are the units of Q? Well, it's pounds. And then what are the units of time? Well, in this case, it's minutes. So what I'm going to do is get in pounds per minute and out pounds per minute. The in pounds per minute is pretty simple. I just multiply these two right here. Because if I do 8 gallons per minute times 4 pounds per gallon, then the gallons clearly cancel, and I get pounds per minute, which is what I'm looking for here. The out is a little bit more work. We're definitely going to use this 7 gallons per minute. So I'm going to write minus 7 gallons per minute times. All right, so I definitely have Q. Q is the pounds that we have in the tank at any given time. So if I take that value of Q, pounds, and divide it by the volume of this tank, then we will get the same kind of cancellation. See, I have pounds per gallon, so I just need to get gallons down here, because if I divide Q by the volume of the tank, then it'll give me what I'm looking for over here in terms of units. So here's the trick, though. C, initial volume, is 60. So you could say V equals 60, but notice we've got 8 gallons coming in each minute and 7 gallons going out. That differential flow rate means that a gallon is being added to the tank every minute. So the volume is going to be 60 plus T. So for each minute, we have an extra gallon in here. Say, for example, this was 10 gallons per minute, and this was still 7 gallons per minute. Then we get V equals 60 plus 3T. And we can still deal with that. So if I do 60 plus T down here, then that would be gallons, and then the gallons cancel and give me what I'm looking for. And remember, we're assuming that this is well mixed, so the concentration of this will be, the concentration within the tank will be the concentration flowing out. So from there, I simplify everything, I drop all my units, I write Q prime instead. So Q prime is equal to, I wind up getting 32 minus 7 over 60 plus T times Q. So notice, as with all of these, it's first order and linear. I'm going to move past this question for now. We're just going to find Q at T, and then we'll worry about part B afterwards. So what are we going to do? We're going to move the, we're going to normalize it. So I'm going to get this piece over on the left-hand side. So I get Q prime plus 7 over 60 plus T times Q is equal to 32. From there, I need to calculate my integrating factor, my mu. So mu is equal to e to the integral of P of t dt, where P of t is the function that's on Q. So that gives me, I'm going to pull the 7 out front times 1 over 60 plus t dt. This is a quick ln integration, which is what they often are. It works nice when they're ln's, because then I can do some e to the work. But what do we get? We get e to the 7 ln, absolute value of 60 plus t. Now, I don't do my plus c here, and there's reasons for that I'm not going to get into. But from here, I got an e to the and an ln, and I would really like to cancel them. In order to do that, I got to get rid of the 7. To get rid of the 7, I use my favorite rule from logs, which is plogging. I can take this and move it in for an exponent. And that gives me e to the ln of 60 plus t to the 7th. And then from there, the e to the and the ln cancel because they're opposite operations. And that just leaves me with 60 plus t to the 7th. And then what I can do now is multiply that by everything on this in this equation right here. And I'll move this over here like that. So if I do that multiplier, we get open parentheses 60 plus t to the 7th times q prime plus, all right, so if I multiply 60 plus t to the 7th by this, I've got 60 plus t in the denominator. My exponents are going to cancel and leave me with 6 of them being multiplied in the top, because the 1 in the bottom will cancel with one of those from the 7. So what I end up getting is 7, open parentheses, 60 plus t to the 6th times q is equal to, don't forget to also multiply it on the right-hand side, 32, open parentheses, 60 plus t to the 7th. So from here, we want to double check that our derivatives line up. So q derives to q prime, and then you always want to check to see if this derives to that. And you'll want to make sure, I should go like this, I should include that plus. It doesn't mess with us here, but there's a negative there. We want to make sure we're accounting for that. But I got 60 plus t to the 7th. If I were to power and chain rule that, I would get 7 times 60 plus t to the 6th. So that's good. These derivatives line up. So what I can do now is write this as open parentheses, because it's reverse product rule, q times 60 plus t in parentheses to the 7th, make this bigger, all primed. Because if I were to derive this, I'm going to scroll down a little bit, if I were to derive this, I would get this line out because of product rule. Is equal to, I haven't integrated yet, 32, open parentheses, 60 plus t to the 7th. Now I can integrate. So I'm going to integrate the left side and integrate the right side. The reason we do this work up here is because the left side is now very easy to integrate. When I integrate this, it's just the integral cancels with the prime here to give me what we have inside the parentheses. So I get on the left side q times 60 plus t to the 7th equals, now I actually have to integrate this side. So I'm going to write my 32. I'm going to open my parentheses. I'm going to write 60 plus t. I got to do my power rule. That's going to take me to the 8th. If there was a coefficient on this t, like I had talked about before, like for example maybe a 3, then you would need to do some chain rule or some reverse chain rule or u sub. I don't have to do that here because I just got a t. But what I do need to do, to do here is to divide by 8 because that's what we do with power rule. So what does that give me? Oh, and don't forget your plus c. This gives me q times open parentheses 60 plus t to the 7th is equal to 32 divided by 8 is 4. That's nice that that works out. Open parentheses 60 plus t close to the 8th. This is a time where we could solve for our c. We will go ahead and solve for that c here. So remember, q of 0 is 15. So I'll write that over here. Oops. So I'm going to use that to solve for my c. So what I do is I plug in 15 for q and 0 for t in this equation. So that gives me 15 times 60 to the 7th is equal to 4 times 60 to the 8th plus c. So there's a variety of ways you could do this. You could probably use a calculator if you want to, and it might be acceptable depending on what the context is. But I'm going to show you a sort of fancy way to get a nice, clean answer here. I see a 60 to the 7th and a 60 to the 8th here. I'm going to start by moving this piece over. I'm going to get a c equals 15 times 60 to the 7th minus 4 times 60 to the 8th. Now, you may say, well, nothing combines there. There's not like terms, right? But I got a 60 to the 8th, and there is a 60 to the 7th in there. So what I'm going to do is write this as 15, not 51. 15 times 60 to the 7th minus 4. I'm going to rip one of these 60s out times 60 and be left with 60 to the 7th here. 4 times 60 is 240. I can do 15. Well, I'll show the work. This is 60 to the 7th. Oops. Times, if I factor, I get 15 minus 240, which gives me a nice clean answer of negative 225 times 60 to the 7th. And then I can just use that all the way through instead of using some messy decimal that's like, I think it winds up being like 6.299 times 10 to the 14th. I'm going to write it like this. So I get this line right here, which is just replacing the c with this value that we found. The next step is divide by 60 to the 7th on both sides. Or sorry, 60 plus t to the 7th on both sides. That gives me q equals, when I divide this into this one, I get 4 open parentheses 60 plus t. Because 7 of them cancel with the 1 there. And then I get minus 225 times 60 to the 7th all over 60 plus t to the 7th right there. I think that's a nice clean answer for q of t, and it's what it is the answer to question A. Find q of t, right? Like that. If you have this as a decimal in scientific notation, that's totally fine. So the last question is, what is the concentration of the tank at the moment it begins to overflow? So you have to be able to look at this and say 60 gallons, 1 gallon per minute being added. It would happen at t equals 30, because that's when it would begin to overflow. So to find the concentration, I plug in t equals 30. That's this work here. I wind up getting 346.831. The units of that are pounds, because Q is the quantity. So the concentration is pounds per gallon. So I need to take that 346 number and divide it by 90. I divide it by 90 because that's the volume of the tank when it overflows, because remember, that's the max capacity. I wind up getting this number right here, 3.854. So that's my answer to part B. That makes a lot of sense. Why is that? Because 3.854 is a little less than the concentration of what's coming in. The concentration of the tank should be approaching the concentration of what's coming in, and this number is about that number, so we're good to go. Hopefully that helps make sense of this problem. See ya.